Okay. So in last class, if you remember, we covered syntax and like explanation for the two types of loops, that is for loop and while loop, and also like we covered demonstration on how the syntax will be, and also I think we covered continue and break keywords. Okay, that is what we covered in the last class, if you remember. And today, to the continuation, we'll cover examples for the looping statements. So today I will explain the different examples of the both for loop and while loop. So it might give you some idea how to use the looping statements. And also I will share the two task lists today. One is on the conditional statements, another one on the looping statements. So please go through and please try to do that assignments so that you can get some good idea on the this conditional looping statements. And even like you may get some couple of days right after this, so you will get good time and you can go through that. Okay. Yeah, now I'm just starting one by one example. So if anybody have any doubt in between the program or while I'm telling the program, please ask me. I will repeat it or I will re-explain it. Okay. So the first program I'm going to be tell you prime number. Okay. So I want to read a value from the keyboard. Okay. So now that value is either prime or not, I need to check it. So for that I'm writing the program. Okay. So prime check, I'm taking an example first program. So first of all, I hope you people all are aware that like what do you mean by prime number? So prime number means the number which consists only one and itself as a factors. So that means that the given number should not divide with any number other than one and itself. So such numbers we call prime numbers. So here technically how to prove surrender, the same logic only. We require to, for example, if you take 10 as an input, so we require to or we keep on divide from 1 to that number. So if any number divides, so for your simplicity, I am taking okay, paint I will take so that maybe you can better understand. Yeah, see here. So my point is, let's take I'm taking an example called 10. Okay, so now the point is, 1 second, keep online, just give me 1 second. Okay. See here, the point what I'm trying to explain. Let's say example, I take a number called 10. Okay. So now you want to check whether this 10 is prime number or not. So what is the logic here is, first we have to start with 1, then 2, then 3. So likewise, you have to keep on trying till the given number. Okay. What is the given number? 10, right? So now, once the number given as an input, now we have to keep on dividing each value to that value, and how many are dividing, we have to count it. Okay. So now, once the all the values calculated, then we have to check for final count. So if the final count is only 2, so the final count is only 2, then it is a prime number. If more than 2, then it's not a prime number. So only 2 means it is prime number. So why? Because as I mentioned already, if any number have only one and itself means it's only 2 factors. So then we call it as a prime number. So now to check the condition, very simple. So we have to first divide with 10 by 1. So here technically, if you want to dividing or not to check, we will use percentile operator. So here 10 percentile first 1, and similarly 10 percentile 2. So similarly 10 percentile 3. So like that we have to cross check. So which are the values giving 0, that we have to count. For example, if you consider 10 is divided with 1, yes, we have to count it. So 10 is divided by 2, yes, count it. So 10 is divided by 3, no, we should not count it, leave that one, okay. Similarly, 10 is divided by 5, so count it. So likewise, finally, after that, 10 is divided by 10. So that also counts. So totally, how many values dividing the 10? 4 values. 1, if you observe that, 1, 2, 5, and 10. So totally, how many values are dividing? 4 values. So the count will be 4. But what is the prime logic? It should be 2. So now 10 is not a prime. Okay. Similarly, if you consider 7. See, 7 if you see from 1 to 7 in between, if you observe that no value will divide. Only 1 and 7 only will divide to 7. So that means the count of the divisors will be here only 2. So that's why 7 is a prime number. The same logic I'm going to be implementing in technically in Python. Okay. So now you see. So first anyway, as I mentioned, we have to read the value from the keyboard. So now n equal to int of. Okay. So why I'm using it, so typecasting into number. So input of enter value. This is n. Now I want to check that, okay, whether this n is prime number or not. So for that, what I'm trying to do, so now I'm checking count variable, that is I'm taking initially as a 0. So now for 1 to given number, so 1 to 10 is 1 to 10, 1 to 100 is 1 to 100, so 1 to n means 1 to n. So 1 I in range of, so from 1 to that number is n, and we have to plus 1 because that also included. And now each time we have to check that whether this n is dividing with I or not. So to do that, I'm writing equal to equal 0. If dividing, what I told you, we require to increment the count by 1. So count equal to count plus 1. So once this loop completed means all the values are cross-checked. Now finally we have to check how many are divided. So if count equal to 2, that means only 2 divided, then we have to write print its prime number. Else, then it's not prime number. Print not prime. So this is the logic for checking the whether given value is prime number or not. So I'm just running this program. Enter the value. Let's take, I'm going for entering the 10. So now you see it's showing not prime. Okay. Similarly, I'm trying 7. Now you see it's showing prime. We'll try some more values. Let's take, I'm giving 33. So it's not a prime because it's division by 11. Let's take 37. So it's showing prime. So likewise, whatever the values you can try and you can check it out. Okay. So this is the simple logic for whether given value is prime number or not, using for loop, because we know how many we need to validate in this logic. So that's why I chosen for loop. If we don't know, then we have to go for while loop. But here clearly we know. So from 1 to that number, we have to check it. So that's why I taken the for loop. So please go through the logic. If anybody have any doubt in any line, please ask. Any doubt? Okay. So now I'm going for second program to the continuation only. Okay. So let's take example. Now in this example, if you consider the value which we given is prime or not, we are checking. Now I want to check, I want to print the list of prime numbers till the value. Example, in this example what we tried, if 10 is the input, we are telling 10 is prime or not, that's it. But now I just enhancing this logic. If I'm giving 10, I want to print the prime numbers till the 10, like what we can say to 1. So 1 to 10, how many primes are there? If you see 2, 3, 5, 7, these are the 4 primes are there, right? So that all what I want to print it here. Okay, so now I'm trying that one. So here in this program, I'm printing the prime number list. Initially, I checked that only prime or not. So now prime list. Okay. So now here I'm taking limit as a input. So because to what extent you want require the prime number. So that is what I'm telling. Enter limit. It's also integer again. Okay. So now very simple logic, same logic, but we have to use two for loops. Why? Because one for loop here, if you see here, one for loop to check whether your given value is prime or not. Now the second loop, for example, now I'm giving the what do you call 10 as an input. So what should I do means, see, if I'm giving now 10 as an input, two steps we have to do. First step, we have to iterate from 1 to likewise till the 10, because now we have to check each value prime or not from 1 to 10 or 1 to n. Now to check each value, like example 1, 2, 3, 10, each value prime or not, again we have to till the loop. So for example here only one time. For example here 1, 2. For example here 1, 2, 3. Here 1, 2, so on 10. So likewise, one loop, this loop is used to iterate the given range of values to check prime or not. And this loop, this each internal loop is used to check whether the respective value prime or not. That means here we have to run the two times loops, one loop outer loop and one inside loop. This is we technically called as nested loops. So here if you see this 1 to 10, if you want to get, now we are writing like for I in, okay. So the outer loop I'm writing for I in range of from, let's take 1 to 10. Okay, this is outer loop. Now in inside for each I we require to check whether the prime or not. So for that again we have to iterate, like for example j, if you consider that is I, this is j in range of, okay. Now again 1 to, but here we have to take I because for each value we have to iterate. Now we have to write the prime number logic here. So likewise we have to write loop within the loop. So if you write one loop within another loop, this is technically called as nested loops. Okay. So nested loops means if you write one loop, it may be for in the for, while in the while, or for in the while, whatever it is. So it is also one kind of notation of the looping statements, nested loops or nested if laga nested loops. Okay. So for in the for. So this logic I'm now implementing in the now prime number list. Okay. So now you see, as I mentioned, first loop I'm taking for n in range of, so 1 comma limit plus 1. So this is the first iteration. And now we have to check count equal to 0, the same logic. Like if you are very familiar, this logic we want to read. Very simple, straightforward, we can copy this logic. But the entire logic should be in the loop. That is the only difference you have to consider. And here, whether the number is prime or not in the previous, but here what is the expectation? If the prime, it has to print. If it's not prime, it should not print. So I'm removing this all things. Simply can write print, yeah, that's it. Because if it is prime, it will print. Else I don't care because I don't want to print it. So here also we use a simplif if you observe that. Okay. So now if I'm running this program, see here. So let's take, I'm giving 10 as an input. Now you see you're getting the prime numbers is 2, 3, 5, 7. And if I'm running the same logic, if I'm giving 20 as an input, see here 19, 17, 13, 11, 7. So these are all prime numbers within the 1 to 20. So likewise, whatever the limit you given, within that limit, all the prime numbers will be printed. So this is the logic for prime number list. And also if somebody asks you like write an example for nested loop, So this is the one of the best example for nested loops. So please try to understand the program, and if you have any doubts, please ask me. I will hold for 1 minute. Okay, so no points. We'll continue the next program. So let's take, I'm taking another example called factorial of given value. Okay. So I want to find the factorial of given value. Okay. So factorial means, let's take 5 factorial means, 5 into 4 into 3 into 2 into 1. So that means the value should be multiplied from given value till the 1. Okay. So that is what the factorial generally. So if you see here, let's take, if I'm taking, right, 5 factorial means here the output how we are calculating. So the traditional approach is 5 into generally 4 factorial. Similarly, it should be keep on drive, and finally it will come like 5 into 4 into 3 into 2 into 1, because 0 factorial will be 1. Okay. So for example, if someone asks you what is n factorial, so simply we can write, so n into, okay, n minus 1 into so on till the 1 we have to multiply. So if you see clearly, observe that, so in this logic we are easily identifying that how many times the loop will be repeating. So n into n times, I can say n factorial means n times. So n times we have to repeat. So I'm able to finding how many times. So that's why we have to go for loop. And remember, this kind of range, if you are able to identify, the very straightforward solution is range function. So range function will help you to generate such kind of values. But only difference here, in previous all examples we are seeing incremental approach, but this is only the example just we covered is decremental approach. See, if you observe that each value decrementing by 1. So now we will see how to decrement the value by 1 and how to find the factorial. Okay. So that is what I want to cover here in this example. So again, here also I'm taking n equal to int of input of nth value. Okay. So now here I want to do that for I in range of, okay. So as I mentioned, it is a decremental loop. So what is the starting value? If you observe here, starting value will be n, ending value will be 1. and each time it is decrementing by 1. So now I'm using, so starting value will be 1, ending value will be 1. 1 means we have to go with 0 because always the range will stop before the value, and each time it is decrementing by -1. If it is incrementing by default 1, you don't require to mention the third variable. But if it is other than +1, it may be -1 or +2 or +5, whatever the other than +1, we should explicitly mention in the range function. But specifically for -1, I mean that +1, you don't require to do that. Now that I value should multiply every time, and we have to get the final result. So for final result, I am taking a variable called f equal to 1. Okay. Now each time this I should be multiplied with f. So f star I. So each time f will be multiplied with f, and we'll keep on getting the result. So this is a final outcome, and now simply can print f value. Okay. And now I'm trying to print it factorial, and now you see if I'm giving 5, so you're getting 120. Now if I'm getting 7, so it might be 5040. Likewise you are getting, but here I missed to validate the value. If I'm giving -5, though see it's giving directly 1, but it's wrong, right? Because negative values does not have any factorial. So that's why before calculation of actual value, you should validate. If n is less than 0, means negative value, you should not do any calculation. Simply you can print it. It's an invalid value. Simply invalid value. That's it. Likewise, L if, okay, L if n equal to 0, for this also don't require to calculate or do any analysis. Simply you can print the f value, that is your 1, because defaultly what is the f value? 1. And now the final case is else. So in the else case, we have to do this all logic for the factorial. So likewise, it is always good habit to coverage the validations, because if user mistakenly or mean that by accident if you given any wrong input, so we should provide a proper valid message to him to understand what he did the mistake. Otherwise, what happened when you go for project or program, it will distract or it will corrupt your application. So it's always better to validate the inputs what we are getting from the keyboard. Okay. So now if I'm running this one, so now you see if I'm giving 5, it will give 120, and if I'm giving -5, now you see invalid value, and if I'm giving 0, now you're getting 1. So likewise for every value it will validate now, so it doesn't give any error in the application. Okay, so this is how we will generally validate the inputs. And there is a concept called exception handling that I will that in upcoming days I will explain. For example, see here in this case, if I'm giving, let's take by mistake I type the JKL something which is not a number, which is a text. Now you see you will getting an error, like if you see invalid literal something is getting. Okay, but it's not really looks good, right? You people may not understand what is the exactly error. Okay, so to provide a better message, so we will use generally exception handling, that is runtime handling. So for that very simple approach here we are following, but I will explain everything in detail in upcoming days, but simple approach. So simply you can put all the code in the try, that's it. Your entire program, I can say that entire program put in the try, and the last you have to write simply except. Okay, except, and write simply one statement. What is the statement you want to provide? You can give it, like example, something invalid data, something like that. Now you see even that kind of case also will cover. Now 5 I'm giving 120, and let's take I'm giving -9, yes, invalid value. And now if I'm giving, let's take KL I'm giving, now you see simply showing invalid data. So likewise also we can handle many more things in the upcoming classes. Okay, but you require to practice more and more to understand first of all fundamentals, so that you can understand more on the upcoming advanced concepts. Okay, but anyway, so this is all the logic about the factorial of given value by using even for loop only. This is also we use for loop, and the same factorial we can also achieve by using recursive functions, but in the functions I will tell that logic. Okay, so please let me know if you are, I mean that getting any doubts or any issues. Please let me know now, and I will wait for one more minute to go for next program. Enjoy. Okay, we'll go for next example. So next, what is my next example here is, see, I want to print the odd numbers, what do you call it, from given range, if you consider, or till the value. So that is what I want to do here. So odd list, okay. So let's take, I'm taking as usual, till what extent you want, you can take limit equal to int of input of enter value, and now I'm taking y equal to 1, and then while I less than or equal to limit. So I value 1 because starting value, and what extent, to the what extent it will till the limit, and each time I'm checking I percentile 2 equal to 1, because if I'm dividing with 2, the remainder will be 1, then it's called odd number. So now I'm printing print I. Otherwise I'm not printing anything, I'm just incrementing the I value to 1. So I equal to I plus 1. So now if you are able to see this program, it will help you to print all the odd numbers for given value. Let's take, I'm giving 10. So now you see 1, 3, 5, 7, 9. So what it is doing, so first it is taking I value as 1, and it is validating whether the I value is less than or equal to limit or not. So the limit what we given 10. So obviously it is less than limit, so it's going inside. So now I'm cross checking whether it is an odd number or not. So for that the logic I percentile 2 equal to 1. If you want to even list, put it as a 0. If it is odd number, put as a 1. So now I'm printing. Otherwise, I'm not doing anything, or I'm not printing anything. Simply I'm incrementing value by 1, because we have to go for next value to check. So now I equal to I plus 1 means it is I equal to 1 plus 1, that is 2. So now again it will check that it is a loop. So it does not go out of the loop until this condition failed. So last day also explained. So always looping statements will keep on check the condition. So till that condition, it will keep on repeating the same code. It won't go out of the loop. Example now, what is I value 2? Is it 2 less than 10? Yes, it will come inside. Now 2 percentile 2 equal to 1. No, it won't print. So 2 equal to plus 1 3. So now again it will check, is it 3 less than 10? Yes, it will less than 10. Now again checking that 3 is odd or not. It will print it. So likewise till the 10 it is keep on printing the values. So once it is reaching the 11, assume that, so now 11 is not less than limit, and 11 is not less than or equal to limit also. So it's not even equal to 10. So now the condition failed. So now from that point is coming out of the loop. So now finally it is getting out of the loop. So likewise the while loop will be executing. So while loop always will executing based on the condition what we given. So the condition if satisfied, it will execute the code what we written. If condition not satisfied, it doesn't check the, that doesn't touch the code what we have. Okay. So this is a simple example for while loop. So please try to understand. If you're getting doubts, ask me. Otherwise, we'll go for this program. Okay, so nobody asking anything. So now I'm going for another example. So it is somewhat interesting example. Sum of the digits of the number. Let's take example. Let's take if I'm giving the input as 123. So the expected output what I'm doing is what I'm asking is sum of the digits of the number, that is 1 plus 2 plus 3. So now the output will be here 6. For example, if somebody asks you like 1 0, let's take 9 something 7. Okay. So now the output will be here. If you observe 1 plus 0 plus 9 plus 7. Okay. So now the final output will be 70. So this is what I want as a outcome of the program. So now if I'm giving an input as a number, this is my input, and I should get an output, this one, and I should write the logic in between how to do the sum of the numbers. This is the logic we should write. Okay. So that is what I'm telling now. So for that, so I hope you understand right till the point. So now I'm explaining. So now you see what I'm trying to do. So first, whatever the number is giving, I will keep on divide with 10 because it is a decimal number. So I need to divide with 10. If it is binary number, I need to divide with 2. So now what I'm trying to do, so 10 ones are, so 10 12s are, okay, 10 12s are 120. Okay. So now what is the remainder here? 3. So if you observe that the remainder itself is one of the digit of the number. Okay. So now keep it as a sum log adjoint. So store into sum. And now we are getting, see, if you clearly observe that when you are dividing with 10, the remainder is 3. Other than 3, what is the number? 12. That 12 is available here if you see. So now what I'm trying to do, that quotient I'm replacing into n value. So now the same logic should repeat for 10 again. So now 10 ones are 10. Okay. Now what is the remainder? 2. So now keep this into some variable, and again we got the 1, the out, so out of 2, what is that? 1 that we are getting here. Now again 1 replaced to 12, and now 10. So likewise you should repeat the same logic until you are getting a value called 0. That is the logic. So once you get the 0, you have to stop it, and this also you should require to add the sum. Now finally please calculate what is the sum value. Now initially we added to 3, and plus 2 5 plus 1 6. So now you see what is the output? 6. We got the 6. So this is the way what we have to perform in the logic to get the sum of the digits. So if you clearly observe what I'm trying to do, I'm writing practically way. See that first the number whatever I'm getting, I'm finding the remainder. Okay, so remainder how to get? R is equal to, I'm doing 123 percentile 10. This is first I did. Okay, percentile 10 remainder, and the remainder I'm storing into sum. So let's take sum is equal to sum plus, because we should keep on add. So sum equals sum plus R. And now what I am doing, the quotient what we are getting, I'm replacing into n. So now n is equal, so here 123 means n, I'm considering as n. Okay. So now n equal to n by 10. These 3 lines, if you observe that, see, 1 time, second time, and third time, 3 times I'm repeating. So 3 times to repeat, we cannot write the same 3 lines again and again. So if I'm writing manually these 3 lines and again 3 lines, we should write, but it's time wasting, right? So instead of that, we have to keep the loop. But here, if you observe clearly, we can't use the for loop. Why? Because based on the number of digits, it may be 3, it will be repeated for 3 times. If the number is 4 digits, the loop will be repeated for 4 times. So based on the digits, the loop will be changed. So that's why we have to go for while loop here, not the for loop. But for while we require condition, right? The condition already explained. What is the condition here? If you remember that, the condition will be 0. Until you are getting 0, you have to keep on repeat the loop. So once you got the 0, you can stop the execution. And remember, the same logic will implement for palindrome number, Armstrong number, for all that logics. This is the common logic for everything. So please try to understand. So see here, what I'm trying to do. First, I'm trying to dividing the given number with 10, and the remainder what I'm getting, I'm storing into the sum variable, and the quotient what I'm getting, I'm replacing with the n value. Like that, I'm keep on doing until the n becomes 0. So that is a straight simple logic. But I hope you understand by the screen. But still, if you're not able to follow, please ask me, I will repeat. Otherwise, I will go to the program. Okay. So now I'm writing the same program. New Python file. Sum of digits. So first, as usual, I'm taking n equal to int of input of enter value. And now I'm taking a variable called sum initially as a 0 to keep on add that. Okay, I'm taking as a 0. And after that, as I mentioned, first we have to write the L, and n condition is n not equal to 0, because if it is 0, we have to stop the loop. Until that, it's keep on loop that. Okay, first I'm finding the remainder. So n equal to n percentile 10. And then I'm adding that into sum. So sum equals sum plus r. And then after, we have to write n equal to n by 10. Why I'm writing double by? Because it should not return fractions. If I'm giving single by, it will go for fractions. And now finally, print your sum. That's it. Simple logic, but internal logic we have to understand. So now I'm doing enter the value 123. See, output is 6. If I'm running 1079, see here it is 17. So likewise, whatever the number you will give, you will get the sum of the digits. So this is the very simple logic to get the sum of the digits, or palindrome or Armstrong, all that same logic. But only you require to understand how this looping is iterating. So for that only explain how that internally each iteration the loop is turning out. Okay. So this is all about your sum of the digits. Okay. Similarly, if you want to do same thing as a palindrome, okay, so simple. The only this line will change, remaining everything will be quite similar to as usual. So let's take, I'm taking palindrome number. Okay, even some of the interest they will ask palindrome for text also. Okay, so let's take here. You see, I'm taking the same code only. Okay, because as I mentioned, right, same code we can use. But only thing, sum equals sum plus r, because we want palindrome means we have to find the reverse number. So I'm taking reverse, and here this line will change because we want to frame the number again. So for that, reverse into 10 plus r. This is the logic. So this is the only one line will change to y, because I written this. See, for example, reverse number means 123 will give you 321. So same logic I will apply. See here. So initially reverse will be anyway, you know, so it is a 0. Okay. So first, what is the remainder value here? 3. So 3 into 0, that is 0 plus I given, if you observe that, reverse into 0 plus r. So reverse initially 0, 0 into 0, 0 and plus 3. So your output will be 3 for the first time. Coming to the second. Already how much reverse? 3. 3 into 10, 30. 30 plus 2. So now second iteration it will be 32. And now third iteration, if you go, what is the value remainder? 1. So some reverse into 10. So 32 into 10, 320 plus 1, 321. So 123 reverse, 321. See that. So likewise, here this line will run out. Okay. And now if I'm printing, you will get reverse numbers simply. Nothing to change anything. So if I'm writing 123, see that? What happened? Oh, sorry, palindrome we have to run, right? Yeah. So now if I'm giving 123, see your output will be 321. See here. And similarly, if I'm giving 1098, so now you see 8901. So reverse number we got it simply. Now only the thing, now to check the palindrome, so only thing, the reverse number, if it is equal to original number, whatever the value we read from the keyboard, if it is the reverse number, then we call it as a palindrome basically. So for that, this input I'm storing in another variable called, let's take, I'm taking into n1 is equal to, okay, because n becomes 0, right? Once this loop completed, if you observe, n will be becomes 0. See here. So final n value will be 0. So we don't have the original value in the n. So to make that backup, I'm taking n1 as a variable. And now I'm comparing if n1 is equal to reverse. So now print palindrome. Okay. Else it is not palindrome. Sorry. Else print it's not palindrome. Okay. So now if you see here, I'm running. So if I'm running 1, 2, 3, so 321. Okay. Not palindrome. For example, if I'm running the same logic 121 and see the reverse number is 121, so it's a palindrome. So likewise, you can check the palindrome values. Okay. And in the chart, someone given the index based. Okay. So 1 second. The chart. So here, yes, see that enter a string. See, this is whatever you return, it is for strings. Okay. But when you go for this one, like here, it is a number. For the number, we can't use this indexing, slicing. We call this is slicing. So this program, whatever Amar is pinged, it is for string. So it is used to check that whether the string is palindrome or not. And here to get the reverse string, it is a shortcut, but I didn't tell you the indexing, but still we can use it option. But this is the program for string palindrome. Okay, it's for not for number palindrome, string palindrome. Okay. Okay. But this is for number palindrome. Okay. Similarly, we have string palindrome. This is the one approach, or else we can use even our regular for loop to find the reverse string, and we can use it. But this is also palindrome string. So any doubts till the point? At the time of string topic, I will explain the string palindrome also. We'll take the next class as that one only. Like we have string methods and string concept, where I will explain all the topics about reverse a string and finding the special characters in the string, or split the words by the string, or reverse the entire sentence. That all topics will be covered as part of your string. Or in the given string, how many special characters are there, or the digits are there. So that all part will take care of the string next class, that is strings, where we will spend a good time with the strings. Okay. And anyway, this is all about your looping statements, as I mentioned. So today I will share some of the assignments with loops and conditions. Please go through that and try to spend good time on that. You will get good knowledge. Okay. And still any more doubts, you can ask me. Otherwise, we'll sign off today and we'll see in the next class. If anybody have any doubts, you can ask me, and you can even if you're able to understand or not, you can even tell me. You can You can speak up now. It's not like one way. It's not webinar. Just I'm speaking, you are listening. You can also speak and you can also ask me doubts or whatever you have. No doubts?
Yeah, Satish.
Yeah.
Can you do it for loop?
Yeah, sure. Which one? Like
Palindrome
this
only.
palindrome?
Yeah.
Sure. Okay. We'll see in the next class. With you using for loop, we'll cover that example. Okay. Sure.
Okay.
Yeah. Any other doubts? Okay. Fine. Take care, Nana. So same as usual. If you want to do the same example for loop, we have to convert it to string and we have to do the reverse of the string. So as I mentioned, right? So that I will cover as part of strings. At that time, I will even cover this example in the for loop also in this case. Okay. Yeah. Take care. Bye bye. So if you have any doubt, you can ping me in the chat also, and I will share the backup videos by today end of the day. Okay. Bye bye. Take care.